Okay, the centre of mass. Essentially this is a point on a body where all the weight, or I could say mass, is considered to be to act through. So a point on a body where all the weight is considered to act through. Okay, so essentially you could have a blank spot, sorry, not a blank spot, like a object. Okay, so plain old object. Just write all this out, sorry. Remember you can press pause. So, let's say I had a object, put one in. Just got a little circle there. Okay, now this thing has weight. Okay, we've looked at that in the last topic, or the last part. It's got a weight. Now where does it actually seem to act from? Because if you actually rotate this object, then it's also going to have weight somewhere else. At all times you could have a point where the weight seems to come through. Okay, so when you roll it round, the weight is always going through one spot. And in this case, it would be the centre of gravity, or centre of mass. So for example, this bus here will have a centre of mass up here somewhere, and the weight through the centre of gravity will be going straight down. The testing it with this tractor, we'll explain how that works a bit later. So how would you find the experiment? Well, you need to rotate your object so you can get a direct line of the weight every time you rotate it. So as we rotate this object around, so we have the object there, you have a weight line going down, then you rotate it around, it'll now be like this. There'll be a weight line going down, and every time you draw on these lines, they'll cross at some point in the middle, and that will show the centre of gravity. So that's the experiment. First you hang a little plug bob to find the straight down weight line, and then you keep turning it around, and they cross over at a certain point. So stability is related to all this. Essentially you could say an object is stable if it doesn't want to tend to move away from its original position. Like, in other words, you move it away from its original position and it'll come back to its original position. Unstable, you roll it slightly away from the original position and it won't come back. Neutral, you can roll it away and it'll find a new position and stay there. Now usually something is unstable when it's the line acting through the centre of gravity, the weight, will go beyond the base. So this thing here, if we look at three sections, 1, 2 and 3, 1 is nice and stable, the weight's acting through the centre of the base. Number 2, it will still return to its original position once you release it, because the weight is pushing on the side of the base you want to land on. However, in this one here, the force, the weight, is now outside the base, and this thing, when you release it, will continue to turn. So we've actually gone unstable by pushing it too far. How can you improve your stability? Well, what you can do is you can spread out where your weight comes from and also lower it down. Okay, so if we look at this self-righting toy, the reason why it's so good is because a lot of its mass is in the very bottom. So the centre of gravity is right down there. Now if you rotate the toy over on an angle, so right around, so if we rotate it around and put, let's say, the head of the guy over here and the base goes around this way, the centre of gravity is still way down here and it's still going through the effective base. Okay, so it's still going to right back again once you turn it. So if you tried it with this girl here, her center of gravity in the middle, okay, goes straight down, you can see that it's actually outside her base, which is the foot, and so that means she'll rotate over. Now the idea is, you can simply look at some shapes. You could have a square, a triangle this way, triangle that way. Which one is the most stable? Well, the square center of gravity will be dead in the middle there, straight down. It's pretty stable. It has to turn over quite a bit for it to fall over. This one, very unstable. The base is tiny, so you only have to move it a fraction, if at all, to actually keep it from turning over. This one, the center of gravity is actually lower probably than the square, so this one is actually probably more stable again. Otherwise you've got to tip it a lot further before the line going through the center of gravity passes the base. So another way of looking at it is, we'll do this in steps. So you have that square, and what you could do is fill it up with water. Okay, so let's say you had the water down here. The center of gravity in the thing would probably be around about here, okay, down there. And so if you actually rotate this thing around, if you actually rotate it around, then to there, so it gives you water, and now change colour. So this one here, now we have the center of gravity up here, and it goes down there. You can still see that it is still under the base. Mind you, the water would change too. If, however, the thing was full, then the center of gravity is higher. It is now much easier to go outside the base. So if you look at a tractor on a slope, okay, center of gravity doesn't go straight down that way, it goes down an angle. The greater the slope, then the more chance it will be outside the wheels. Okay, so a tractor needs to try and have its center of gravity very low so it can stay stable for as long as possible.